Hi, this is Ben Hagman, and I'm doing my presentation on the definite integral. The definition of an integral. If f is a function for x's in between a and b, we divide the interval ab into n subintervals of equal width. One way of seeing this expressed is delta x, but delta x is the same way as saying change in x. So in order to find our change in x, a simple way of doing it is b minus a divided by n. We let x0, x1, x2, and all the spaces in between up until xn, which is our endpoint for these subintervals. Then we plug these subintervals in back into our equation to find the heights. And then after we find our heights, we then take our heights, multiply it by our widths, and then we're able to find our area. This is the definite integral from a to b. Provided that this limit exists and gives the same values for all possible choices of sample points, if it does exist, then we say that f is integratable on a and b. Breaking down the integral. At the beginning of the integral, there is a elongated s. This is the integral sign. The next part of the integral is f of x. This is called ingrad, and a and b are the limits of integration. A is the lower limit while b is the upper limit. And for now, the symbol d of x has no meaning by itself, but it actually means to do the antiderivative of our function. And this process is called integration. The next thing we'll be talking about is the Rhine sum. So the Rhine sum is equivalent to definition 2. And definition 2 says that the definite integral of an integratable function can be approximated to within any desired degree of accuracy by Rhine sum. If f happens to be positive, then the Rhine sum can be interpreted as a sum of areas approximated rectangles. By comparing definition 2 with the definition of areas, we see that definite integrals can be interpreted as the area under the curve. F takes on both positive and negative values. The Rhine sum is the sum of the areas of the rectangles that lie above the x-axis and the negatives of the area of the rectangles that lie below the x-axis. The Rhine sum is an approximation of the net area, while the definite integral is the net area. So that the definite integral will give us an approximate answer to find the area under our curve. The next thing we'll be talking about is one of the two theorems. This theorem discusses is that we have defined the definite integral for an integratable function, but not all functions are integratable. The following theorem shows that the most commonly occurring functions are in fact integratable. And this theorem says that if f is continuous on a and b, or if f has only a finite number of jump discontinuities, then f is integratable on a and b. That is the definite integral. So now for the second theorem. If f is integratable on a and b, then the limit in definition 2, which we discussed when we were describing the Rhine sum, exists and gives the same value no matter how we choose the sample point. To simplify the calculation of the integral, we often take the sample points to be right endpoints. And so what the theorem is saying is that if f is integratable on a and b, then integration equals the Rhine sum, where delta x equals b minus a over n, which is the change of x, and x sub I equals a plus ix, again, which is another way of saying change in x, delta x. So now we're going to apply an integral and use it to solve. So we're going to use x to the third, or x cubed. So we want to integrate x cubed from 2 to 4. So the first thing that we're going to do is find the antiderivative of x cubed, which would be x to the 4th divided by 4. After we find that, then we're going to plug in our values. We're going to plug in 4 and 2. So we plug in 4 and 2, and then after that we evaluate. And you'll notice that 4 over 4 to the 4th is just going to be 4 to the 3rd, minus 2 to the 4th over 4th is going to be 16 over 4th. Simplify, and you get 60 is your area under the curve. Now, actually, funny thing is that I noticed a mistake while I was making this, is I did a plus c, but you don't have to add the constant when you're doing with definite integrals. You only add plus c, or the constant, when you're doing indefinite integrals, and an indefinite integral is when you have no limits. There's no a and b. And that was my presentation on the definite integrals. I hope you were able to understand how to use a definite integral and what a definite integral is. Thank you.